Okay, so in previous video, I explained the very basic of protocols. Now let's give it a more practical way. So why should we use protocols? It would be your answers. And let's deep dive more and let's see. For example, let's remove these things and let's remove these things and let's remove these protocols. Okay, and let's mm, comment out the users and let's see. User can be different. For example, let's assume that a user can be of different roles. For example, user can be admin, or let's think something like real life example. So let's extract something new and let's think about, okay, so let's think about electronics systems and let's think about employers and admins and okay, so let's let's make a protocol. Let's name a protocol called user and let's rename this to refactor, rename this to admin. Okay, so admin. All right, and here also let's remove these things and here admin and here mm, admin pest pest. Okay, so let's also pest. Good. Okay, so let's move this all thing here. See, and let's like let's comment out the whole thing because we are, I think these things are not going to be enough. The why does the mouse become stacked? I don't know. Let's see. Shit. And let's cut out this protocol. Electronic electronic device. Electronic device. Okay, so and in the electronic device, let's var name get and set and again, so var price get and set and then var is on because almost every electronic device has this property is on or is off, right? And then again var brand. Okay, so electronic device must always have brands, we know. And then another thing called warranty period and then var power consumption. Okay, now it has to be also a function turn on and a function turn off and a function display info and another function called function warranty ended, and another function let's call. These all are abstract. And calculate energy, uh, power uses. Okay, and calculate no, calculate power uses. Okay, so these are enough for testing. Now let's add something here. So electronic device is a protocol, right? Now, and these are properties and these are functions, abstract functions. Now let's add a struct. For example, mm, electronic device. What can be electronic devices? So light. Okay, so light, and let's conform to electronic device. So it's an electronic device, electronic electronic device, and it will throw error because it should conform to protocol at all the steps, right? Okay, so this added all the things we needed for an electronic device, and we don't want to keep the unnecessary spaces, right? And the functions, let's keep empty here. Let's return something empty here, also same thing, and here also 0.0. Okay, now what extra properties the light can have? For example, the light can have bar brightness, and then the light can have color temperature, and it can also have is dimmable, and it can also have um, bar is smart. Okay, okay, so we created a struct which is electronic device, so we have to add all these things what electronic device commonly have, and these things are extra properties of light. Now let's create another struct called um, television. Okay, so television, and this is another electronic device. Now let's add all the steps of this electronic device. Okay, so let's copy paste these things, control C, and then here also same thing, right? Same thing, so control V. All right, but a television has all these things like brand, power consumption, price is on or off. Now let's see what else, because the light doesn't have screen size, but television has screen size and resolution, and smart TV and has HDR, and what else can it have? For example, where has Bluetooth. Okay, so these are enough. You can see both are electronic devices, but television has some extra properties and light has some extra properties, but both are electronic device, so the common properties are also present here, right? Now let's another struct called computer. Yes, this is a very let's add computer. This is a very important electronic device. Now let's add the steps of an electronic device. So these are common, so we added these things, and let's turn off, and here and here is 0. Okay, now computer has some extra properties, for example processor type, RAM size, storage size, graphics card, is gaming computer, and some other things. Let's add var has touch screen and is laptop. Okay, so computer, we added computer, television, and light. Now let's add another struct, another electronic device. For example, struct mm, smartphone. Okay, so smartphone is also electronic device. So let's confirm to protocol and all the steps. Okay, so turn on, turn off display info, and here is 0. Okay, so this is good. Now smartphone also have some extra properties. For example, were screen size, then were camera resolution, were has 5G support, battery capacity is foldable, and let's add another simple thing called were is water resistant, and were wireless charging, and face recognition, and fingerprint scanner. So these are enough. So we added so far how much? One, two, three, four. Okay, let's add another extract called refrigerator. So extract refrigerator. So electronic device, and let's add these steps here. Fix. Okay. So price. Okay. So turn on here. Same thing. Same thing, and here it should return a string, and here 0. Okay, now refrigerator also has some sort of capacity, has freezer, energy rating, smart freeze, and has water dispenser and ice maker. Okay, so you can see the electronic device has some very common properties called name, price, is on, brand, warranty period, and power consumption. And these are the common functions to turn off or turn on a device: display device info, and calculate warranty end date, and calculate power uses, right? And we created a few electronic device: light, television, computer, and smartphone. But the structs, all the structs are electronic device, but each of them has some extra properties as well. For example, light has brightness, color, temperature, is dimmable, is smart, but television doesn't have that properties. Instead, television has screen size, resolution, is smart TV, has HDR, has Bluetooth, and computer has some own properties called processor type, RAM size, storage size, graphics card, is gaming computer, is laptop, is touch screen, and refrigerator and smartphone also has some extra own properties. For example, has 5G support, camera resolution, is foldable, is water resistant, and many things. And refrigerator has capacity, has freezer, and etc, etc. Okay, so we created some electronic devices, um, which all of them are electronic device, but all of them has some own attributes as well. So let's use them in this electronic devices. Now let's add a state private var, and it isn't light, so let's cut it. The AI generated these things for us, so let's state var devices. So let's available, available devices, and they should be, all of them should be electronic device, right? Now let's initiate some of them. For example, I have an electronic shop, and i I have a light which is electronic device. Okay, and I have a television, and I have a computer, and I have a smartphone, and I have a refrigerator. And again I have something, another light, and smart light, and then I have another refrigerator. What to fix? Insert. Okay, so another television. Okay, so good. So computer. So as you see, our views variable, the state variable will accept only electronic device, right? And whatever device it is, it will accept electronic device, and if it is not electronic device, it will not accept it. So for example, let's create another electronic device, struct. For example, what electronic device we can, um, for example, washing machine. So machine washing machine, and let's not conform to electronic device, but it is an washing machine, so it is also electronic device, and we add some things, warranty period, and var local capacity, load capacity is front loading, and has dryer, and energy rating is smart washing machine. Okay, so these are enough. So in this washing machine, it doesn't conform to protocol electronic device, which we did here, 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 and here. But the washing machine, though it is an electronic device, we didn't conform to electronic device, so we cannot add this here. So let's add washing machine, and let's add this, but this will throw an error because the available devices will only accept those objects or those structs or those data which conforms to electronic device only. So this should be electronic device only, and to add in this array the washing machine, we should also add it like this. So it should be an electronic device also, and if we add those stuff, and then this will work 0, and then calculate warranty, string turn off and turn off. Okay, so you can see it's now accepted, right? So you understood what we what and where and why we should use electronic use protocols. So each electronic device, it will only accept an object of electronic device. So these are available devices, and all are electronic device. So let's print them all now. So list, and make a list of count list. So for each available devices, and id dot name device in h stack. Okay, so let's not for each, let's edit list views are professional, so let's make it a list. So list list, list, and now hmm, for each device in, and here let's add some text. Device dot name, and okay, let's make it like h stack c and control v, then spacer, and then text device dot, sorry, text, okay, so device price specifier foreground color gray. Okay, let's remove this. So you can see they are showing. Now let's, okay, so you can see they all are objects of, they all conform to electronic device, and they all are electronic device, but all of them are different structs, but though they are different struct, we are able to list them in an array because they, in the array we kept that they should be all electronic device. So this is a little understanding of how protocols work. You can see LED light, smart TV, and gaming PC, flagship phone, smart fridge, smart light, 4K TV, MacBook Pro, font load washer, and many things, and their prices as well. So prices and this data all are loaded by AI. So thanks to AI, though I don't like AI very much because AI has pros and cons, everything, but in programming, a little bit help it does anyway. And however, you can understand why and how protocols are used. And in real-time applications, you must use protocols to keep your application code maintainable, reusable, and better optimized. Okay. Thank you very much for watching, and let me know your comments in comment section, any questions, and don't forget to subscribe. Thank you very much.